I'm sorry, I forgot to start doing that. I'll do that as well. Okay, so the first thing I want to do is to share a screen, which I think will be useful just to sort of hear, to give you some historical perspective. I'm going to give an overview of let me see if I can find it here. Here, let me open it up. Again, I have too many windows open, so let me do this. All right, let's just take a second. I should have had this ready. The other thing, while I'm getting this ready, the other thing we're going to do is going to just have a couple of readings, just to sort of make some things to think about how these issues relate to mathematics. Okay. So you should be seeing a really ugly flowchart-ish kind of thing. And if you're not seeing it, just let me know.
Yeah, I think it's not showing up.
Okay. Thank you. How about now?
Yep, that did it.
Good. This is just going to be a guide. Like I just wanted to give a sense for the flow of history, and you'll see dotted lines and things like that. And right now we're talking about the ancient mathematics. So stuff that roughly took place, we think, as far back as 3000 BCE. The math we're talking about is more around 15 or 1600 BCE. But the idea is, sort of that these non-European cultures, Egypt and ancient Babylon, were sort of developed mathematics, and you're working on the quadratic equation with Babylonian mathematics, and then we've looked at some of the Egyptian mathematics, and the math, I wouldn't say the math is trivial by any means, but it may not be what we would study in grad school today, but there's definitely clear mathematical thinking, whatever that is. That's kind of an undefined concept, at least in this class. But I think we can all recognize that like when you look at Egypt, they're talking about summing like a geometric progression, and there's, to figure out all those unit fractions took some computational power and skill, and then you've only just scratched the surface of the Babylonian mathematics. But there's definitely a solutions to the quadratic equations, again using plural, that work. And there's that one in particular that one of the groups is going to report on, and I'll share the links. I mean, you can just look at everybody else's links, but it's sort of a procedural way to do the quadratic equation that sort of has surfaced recently. It has its roots in ancient in the Babylonian mathematics, and it's procedural rather than using a formula and plugging in. And when we talk about different ways of looking at math, I think that's a great example, because I think our, the modern Western version is to look at an equation and plug in stuff. But this is a procedure that works. And so it's a different, it's a different point of view about what do we mean when we do mathematics. And so, we're starting our discussion with Egyptian and Babylonian mathematics, which again is non-European. And I'm trying to show where, that we end up way down here at around, somewhere in the 1600s after the, BC, in the Common Era, as they say. Okay, so there's I'm putting a question mark, but I think it's evident that there was influences on the development of Greek mathematics by from the Egyptian and Babylonian or Mesopotamian mathematics. But it's unclear. Those links aren't clear. And so I got in trouble for suggesting too strong of a link, and you'll see that later today. I was doing it in context that I think is relevant to what we're talking about today. And then one thing I'm noting, is that it's unclear. I do not study Greek civilization. That's not an area of specialty, but they use slaves, and so a lot of Greek culture is based on slavery. And Greek, so there was a normalization of that. And when you think about what the founding fathers in our country did, a lot of them sort of had a reverence for the Greeks and the Greek democracies. And so that notion of slavery was normalized to some degree. And there's different people can debate upon how much of an influence that had on the founding of the United States, and our failure to get rid of slavery when we had a chance early on. So I just want to point that out, that was part of the culture as well. And I'm not saying other cultures here didn't have slaves, but we do know about the Greek culture. So that's one line of development. And notice there's no line between Greek and Europe that's direct. You see this dotted line that goes later to about 1600. And I'll discuss that. So at the same time, I should have drawn an arrow here and here, not at the same time, but so the Greek Empire sort of flourished for about 1,000 years. And then at around 400 Common Era, it sort of, what was left of it was just sort of evaporated and was subsumed by other things. And we'll talk a little bit about that. And about 350 years later, a little bit less than actually, after the death of Muhammad, that there's a civilization that grew up in the Mediterranean basin, especially after the wars of succession were fought, that had very sophisticated mathematics. They had a center of learning called the House of Wisdom. And what the Caliphate did is they brought together people from all over that they knew about, all over the Mediterranean, that knew mathematics and knew other things. And it was to sort of spread and conserve knowledge. So a lot like a university. Again, we'll talk about that when we talk about Arabic mathematics. And then about 760, that should be CE, not BC. It's Common Era, so 760. So right around this time, there were some visiting scholars from India that came in to visit the House of Wisdom, and they brought knowledge of trigonometry. They brought what we see now as our number system, which is called the Indo-Arabic number system. And I'm not sure about the influences of China and Japan on India. So the point is that this Arabic mathematics came sort of from the Greeks and also from the ancients, and also with some influences from India. And that sort of developed, and then the development there just sort of stopped around 1200. And we can talk a little bit about that. And then again, about 1200 in the Common Era, Fibonacci spent some time visiting Arab mathematicians, and he wrote a book which introduced higher mathematics to Europe, and the higher mathematics being the mathematics of the Arabic cultures. So while Europe was sort of floundering in the medieval times or the Dark Ages or in tribal wars, there's this culture, sort of one of the most advanced, probably the most advanced culture of its time, was flourishing in the Mediterranean basis. So sort of and it often goes by the name of the Arabic culture. And so the mathematical influence came through Fibonacci, and then also there was also some Italian algebraicists who worked with things like the solution to the cubic equation. And they were sort of separate from Europe. And this time in Europe, even though Italy is part of Europe, so between 1200 and 1500, Europe was tribal. It was fractured. There wasn't a lot of community. There was nothing remotely like what is going on today. And so there was just a lot of cultural isolation and developments happening in different places. And so sort of this critical mass through the Italians, through the Arabic mathematics, through the Italian, but also at the same time Europe just started to develop a lot of ideas, and we'll look at these, started to sort of come about. So we have this sort of creation of the advent of the calculus in around 16 to 1700, I'm going to put it. And some of the Greek works were being rediscovered. And as you'll see, there was kind of a preference for what the Greeks did, though not completely. And so the point I'm trying to make here is that the European mathematics, which is our dominant mathematical culture, was really late in developing. So I don't think it's an exaggeration to say the Europeans were quite late to the game of advanced mathematics, except for the Greeks, much earlier. And so I just want to point that out, that our sort of dominant mathematics is a specific way of doing mathematics. It inherits a lot from the Greeks, but it's ideas that came about sort of strictly in Europe. And there are other ways to conceive and think of mathematics. And one of the things I want you to do in your project is to look at some of those sort of other ways of thinking about mathematics and find out what about those is different. And I'm just, the point is that we have a way that we think is the one way of doing mathematics. And I'm guilty of teaching that in Math 101. That's what I teach in Math 101. That's sort of the gold standard of modern mathematics. But that doesn't mean it can't be critiqued and thought about at the same time that we sort of embrace it. But so when you do these projects in a couple of weeks, I'm gonna ask you to think about some of these non-European origins of mathematics, and what different ways of mathematics they suggest. And then also over here, the mathematics of Africa was real, and the same with Latin American, especially the Mayans. And that doesn't seem to have an influence. That's why it's off to the side. And you could put probably the mathematics of other parts of Asia over here as well. So one of the things that when we develop this project, the third presentation, is I'll give you some latitude in choosing things. But I want you to start thinking about that now. And so I'm just trying to put this up here, one, to get you thinking about that, and two, to get you thinking about how we've constructed a particular way to do mathematics. And it may not be the only way to do it, but it's the way we do it. So it's important to understand it. So that's kind of what I have to say about this. And this picture is sort of my way of trying to tie together some of those ideas. But questions or comments, I know it was very, and I don't think talking for long goes well over Zoom. So it was just an overview and just trying to get you to think about that. But do you have specific questions or comments about that? Okay, this is posted in the, I think I have it called it the Scholar Strike section of the course. So this is posted. Okay. So that's one of the things I wanted to talk about. And then I posted some readings, and I think I'm going to ask you to, I'm going to make groups, and you can look at these readings, but there's two readings here. I'm going to go September 8th, Critiques of Eurocentric Math. That's what I called it. And I'm going to share the screen so you can see what I'm doing. And you should see the Blackboard site. If you don't, just let me know. Good, thank you, Daniel. So here's an article. It's maybe 10 pages, and it's written by a math educator. I'm going to ask you to download that and look at it and read it. We're going to break up into groups. I'm going to give you about 15 minutes to read, and then maybe another 10 or 15 minutes to discuss the readings amongst yourself. And then I'm going to ask each group to sort of give a quick synopsis to the whole class about your readings and any thoughts you have. And the first reading, you'll know the article when you see it. It's by somebody that you know. And it's about sort of how in the 1600s, some of the mainstream mathematicians viewed Arabic mathematics. And this has to do with everything with styles of doing mathematics and way of doing mathematics. And I'll talk more about the context of that. So it's just a short article. It's very readable. It's about 2 pages. So that's one of the articles I'd like you to read. So you'll just click on that link and go to page 6. And again, you'll see the article. And you'll know the one when you see it, because it's called Dirty Math. And again, it's by somebody you know. And then there's a PDF I'm calling it a critique of white mathematics, and it's by a woman who wrote. She's Latina, and she wrote an article about sort of whiteness in mathematics, and just got all kinds of really nasty emails. And this is about the reaction to what she did, but it also poses some questions which I think are worth thinking about. So I'm just giving you some things to look at when you read it. And so read like pages 8 to 16. There's a final section on a revolution of mathematics education, and we can read that later just to keep it manageable. So I want you to sort of form the groups and just which I'll do in a minute, and they won't be your presentation groups. They'll just be random groups like we do in this class. And just read the articles, take notes, and discuss it. And I'll check in from time to time, and then report back to the class. Just, you know, maybe appoint somebody to do the talking, or draft somebody, and just sort of just give reactions, what you think about it. I think this article, you'll see why I agree with most everything in this article, the dirty math article. But this article, there's things I agree with, things I don't agree with, but there's nothing in there that's not worth, I think, thinking about and considering. So you know, I think it's very good if you're doing mathematics education to think about, because it's talking about some ideas that I know are current math and just in the discussion of mathematics. Again, so I'm going to break you into groups. You have this 2 downloads. I'll let you do those and meet in your groups. So I'm going to stop the share, unless if there's a question about it. But if you have any questions, either interrupt me or, you know, unmute yourself and talk, or put it on the chat. So not hearing anything, I'll stop the share. But I'll give you a couple of minutes to break out. Okay. Sorry. So I'm going to put people in 4 groups again. That's going to be 3 to 4 people in each group. And I'm going to create the rooms now. And then I'll open them up. So it's.
Okay, cool.
I'm just checking in to say hello. I guess are there just 2 of you in this group? I guess so. Yeah.
Yeah, it's weird.
Well, that's because they considered me a person. So I'm going to move somebody else from another group into this group. I thought there were 3 of you in here. So I'll be back in a sec.
Okay.
Okay.
So you didn't get put into a room. I'm going to put you in group 1. Oh, somehow you. Oh, Valsa, are you there? Are you there? Oh, you joined. Okay, good. Okay, for some reason, when you was late joining the room, so I think you got. I'm just sort of just checking in. Does everybody kind of get what they're doing?
Yeah, just a general discussion after reading it.
And read it and then discuss it. Yeah. Okay. Good. Okay. I'll let you be for a bit. If you have questions, just ping me. I'm just checking on each group.
Okay.
I'm just checking in to see, make sure everybody's clear on the process. Just, you know, spend some time doing the reading, then discuss it, and then have somebody just sort of summarize what you discussed.
Sounds good.
Okay, good. Okay. If you have any questions, just ping me and I'll join. I'm just checking in, seeing how people are doing, making sure that you're clear on what we're doing.
Yeah, I think we got it.
Okay, good. That's what I thought. Okay, it's pretty straightforward. Okay, if you have any questions, just ping me.
Sounds good.
Or, you know, if you feel, if I'm not back and you feel the discussion's run its course, let me know that as well. Okay, okay, see you in a bit. Just checking in to make sure everybody's understands what we're doing and everything. I'm guessing you do, but just double checking.
We're reading your article.
Yep.
Okay, good. And then, we'll talk about these, later. If you have any questions, just ping me, and I'll probably check in a few minutes. Okay, so I'll leave you be, and just remember to appoint somebody to report out.
Yep, Bryce should do it.
What? No, you're the one who wants to talk so much.
No, I didn't want to talk at all.
That's funny. Okay, have fun. I'm going to leave you alone to do that. Otherwise, I'll just appoint somebody. Okay, talk to you later.
All right.
I'm gonna take some time, so give me a few more
Hello.
minutes.
Hello.
Oh, it's back.
Just check. You want to just read both articles, right?
Yeah, yeah. And you don't have
Okay.
to, the second one, just read up to that. You don't have to read the last section about revolution and mathematics education. Okay. Are you still reading or?
I'm still reading. They're both done.
Okay. I will come back later, see how you're doing. I assume people are still reading?
Yes.
Yeah, okay, good. Okay, just checking in. That's fine. It looks like people are still reading, so I'm just checking in to see, kind of see where people are. So no need to respond. I'm just gonna step out. Just checking in for a second. Looks like you're still reading, so that's fine. I'm gonna step out.
knowing more about math, it's a step backwards because it's being tainted.
Mm-hmm. It's like it's being diluted with geometry. Or no, was it originally geometry? Either way, whatever it was being diluted with something else is kind of a scene.
And also, I think found that he was trying to analyze it and like create new like analytical art for it instead of just like trying to find out what's the secret behind the Greek idea and stuff. Is he the one who find geometry? I mean, geometry or something like that? Oh, never mind.
Hello, Alexander.
Oh, I'm sorry. Was that I just sort of was it Kika? Was that a question for me?
Oh, not really. But I was just wondering that French guy.
Yeah.
Why do he see? Why do he trying to like analyze Greek ideas instead of finding the secrets of it?
Well, bring that if you have questions like that, bring them up to the discussion. I'll definitely address that.
All right.
Okay, I'm happy. Yeah. So if you have comments, questions about any of the readings, agreement, disagreement, just kind of talk a little bit about what your discussion was about. Okay, and I'll give people like another 5 minutes or so. It looks like you're in the discussion. Okay. Okay, so I'll leave you be. I just kind of wanted to see where you were, so I'll leave you be and check in with the other groups.
All right.
Oh, you're a quiet group. Are you still reading? Or have you discussed?
There's a lot
I
to
still
read.
have I still have a couple pages left.
Yeah, we're going to probably go back. So why don't you just, if you're not done reading, just go with what you've read so far. And then,
Okay.
and when you report back, you can bring questions that you had, reactions, comments. Just want to generate a little discussion about it.
Okay.
It's about, I was going to kind of bring people back a little bit, maybe a little bit after quarter of, so maybe in about 5 minutes, a little bit less.
Okay.
Okay. So if you're still reading, I was going to suggest that maybe stop reading and I'm going to bring people back in about 5 minutes and maybe discuss what you've read so far. And you can bring back questions or comments, reactions to the group. So kind of, I don't know, have you already had time to discuss? Okay. So again, maybe break off in the reading, and then I'll give people a few more minutes to talk, not that much longer. Just have a discussion about, reactions, and then have somebody report back. Is there any questions? Are you all still reading, or have you already had your discussion?
We're still reading.
Maybe just in the interest of time, maybe just start talking, and discussing what you've read so far. And don't worry if you haven't read everything. And if you have questions or reactions, just again, when you report out about what you did, bring those to the whole class.
Okay.
Yeah, I'll leave you to discuss. Again, but I think like my suggestion would be to stop reading just in the interest of time, and just discuss what you've read already. There's a lot in the reading, so I think there's plenty to discuss.
Oh,
Hey, Daniel, were you asking me a question, or are we just starting a discussion?
Nope, just starting discussion.
This is awkward because like in a class, I can like, you know, hear where this, it seems like I'm sneaking up on you and stuff like that. But so anyway, I didn't mean to do that. So I'll let everybody be for like another 5 minutes or so. Okay.
Okay.
everybody's back. I just kind of wanted to start off with a question. I mean, is it just math? Is math just math, or do we really need to think about these things when we either communicate math or teach math? Or should math be somehow separate from all that because it's just this abstract thing?
I know for me, I never imagined math and I guess this type of thought, like this type of topic to come up in a math course. I always viewed math as like this very objective, completely separate thing.
And you may be right. There's, but that's kind of what I used to think. That math, one reason I like math, because it was like, I'm engaged with the world, but it's also like all the problems of the world, you just kind of leave them and come into math world, and so that, I think that's a question that we all should think about. Okay. How about other people?
Well, I would have. Oh, go ahead.
You can go, it's fine.
Okay.
So I would have thought that this would only really be a problem with the surge, with the kind of surge of right-wing thought. I guess right-wing thoughts with Trump and all that. But these papers kind of open your eyes a bit about how this might have existed even before in like kind of the elitism of science and math. And that's something that I haven't thought about. I would have, if you told me this now, I would have thought it was just something that came about from a kind of modern thoughts, but maybe not.
Uh-huh. Hannah, it looked like you were about to say something.
Yeah, I was gonna say, like, I feel like growing up, I always thought that math was like the same everywhere, like no matter what culture or country you were from, like the math would be the same. But, reading this was kind of like, it started from different places, and with a lot of things, like the dominant culture kind of like took over the math too.
Okay. Other thoughts? I mean, I'm going to be really honest. Like I said before, that's the way that I view math, and it's never too late to learn, and maybe I'm a slow learner. But like a lot of these thoughts, I haven't really thought about until the last few years, and one reason I thought about them was I was in a building, Howard, that had English majors and sociology people and cultural studies people, and they're always talking about, stuff like this. And so I was kind of jealous, we don't do that in math, we don't do reading in math, like where you get to read and share and stuff like that, like we did today. So I think I find a lot of this stuff eye-opening, and I wonder, like you've had, most of you had me in 101, and I'm not, I'm pretty hard-assed about, you've got to do it this way, and it's partially so you all know that, but I think it's also a struggle for some people, and I wonder how much of that, I wonder how much some of what I read, I just read this article for the first time last night, I wonder how much these issues affect that. And, so it's made me kind of like, maybe I need more disclaimers in that course, or do some other kinds of math as well. But like, it makes me think about that. So anyway.
Can I point out that, well, first off, I'm not from the US, I'm from Bolivia.
Yeah.
And I really don't know how this would apply internationally.
Mm-hmm.
Because like say in Bolivia, it's really homogenous in terms of race.
Uh-huh.
So, I mean, elitism comes more from social class than from race. So I'm not sure how this would apply in places like Latin America, for example. I would really like to look into that.
Uh-huh. Yeah, and I think that my own personal opinion is I agree with you about what you're saying about class. I think that applies always. I mean, it's a lot of different factors. I think that's an article that maybe this article doesn't talk about that too much.
Well, I think a decent part of it is the fact that while math is about numbers, it's still studied by people, and people are always going to bring their own biases into everything they do.
Yeah, and some of the biases can hurt students. Like, there was a lot of, I'm sure some of the women in this classroom have experienced some of this stuff, but when I think it's much better than it was. But I mean, my first students I was teaching when I was in my 30s, and my first students were adult students, and they were coming back to learn. And, you know, one of them had told me that, you know, her teacher said, you're a woman, you can't learn math, you know, and she was kind of scarred from it, you know, and so a lot of it has to do, you're right, Bryce, I think with the people that teaching it, you know, and the attitudes. And I think within math, there can be, I know math, therefore I'm smarter than you, you know. I mean, I think we've all run into that, and we maybe, you know, maybe we're all guilty of it. I don't know, you know, but I think that's a good point.
Yeah, I think I experienced this kind of issue before with some teachers, and I always try to challenge them back by, you know, proving some new solution for them.
Uh-huh.
But obviously they're the teacher and they're just gonna write F on my paper. And I was kind of pissed at that all the time.
Well, good for you. It's an honest F, you know. So I was going to ask about groups reporting out, and that was, I'm just curious, we don't have to go in order or anything, but what kinds of issues came up? And it could be about either article.
I mean, I can share.
Sure.
I can share a couple of the points that we had brought up as a group. We didn't necessarily get super far into the second article, but in the first article, a couple of the key things we pulled out was this like elitist idea of math, and how like people were so quick to judge and then like attack other people's works, and where we talked about now, where all of like academics and research is like kind of valued, and even if it's not necessarily true, it's like you take all of that work that somebody else has done and you take that into consideration. And so like something would be considered good academically based on if it was useful, not based on if the person who created it was right or wrong. And so that was something we thought about when we were reading the first article.
And you're talking about the dirty math article?
Yeah.
My article, yeah. And you should ask some of your other teachers about that, because I've been at conferences where people get really mad at each other, and it seems silly to me, you know. So it's like it's all, you know, it gets into a lot of different things, you know. Even in history of math, I'm talking about people, you know, it's not about this kind of stuff. It's about interpretations of history, and you know, people feel really strongly about it. And, you know, I wouldn't want to have been on the receiving end of some of those. So other things, or even questions that arose?
I just thought it was kind of interesting how, you know, some news sources, Fox News and other ones, kind of took what Gutierrez said and made it into completely something else, and try to frame her as like someone she's not. And then I mean, it kind of relates to the other one too, where Viette kind of disregarded the Arabic math, and then he was trying to just use the Greek stuff because he thought it was better for some reason. And another thing, I guess, towards the end of the second one, Gutierrez provides like ways to revolutionize math education. So it kind of ended on a positive note.
And I don't know. I think there's a couple of people that here in math ed. You don't have to identify yourselves or anything like that. But I'm, you know, it sounds like some of these ideas about social justice, at least, and are coming up in education. From what I can tell, some of the organizations were putting an emphasis on that. Okay. So other groups, or you know, what came up? Any questions? Go ahead. Go, Daniel. Yeah.
So in my group, it came up how it was a bit of a hypocrisy how I can't remember who said that Archimedes or one of the Greek mathematicians, like they said, oh, they have to be simple-minded or barbaric or whatever because they don't share their methods, and then they themselves would closely guard their methods so that they could have a step up on their peers or at the time.
Yeah, a little context about that. Like we'll talk briefly about Viet and or Viete, and even Descartes and Fermat. And there was a sense, especially with Fermat and Viet, that they were discovering not only new things, but their discoveries would unlock every secret in the world. You know, there was this optimism about their own capabilities and the capabilities of humans. And we're going to come back to that issue. So remember what he said about the Greeks and their low cunning and hiding the methods. We're going to hit that one. We're going to look at that issue from a different from the Greeks' point of view, actually. So and you notice that there was sort of this privileging of geometry as being more beautiful than algebra, and that algebra was kind of grubby and and dirty, and and one reason for that is that algebra, one of the ways it was conceived around Viet's time was as a way to do geometry and cheating. So when like it's just too much easier. You to use algebra, it's cheating. You're not using the geometric methods of ruler and compass, because you could actually solve an equation. And you notice, I'm guessing some of you, when we looked at the quadratic, I know my first reaction was to use algebra. And I don't know how many of you had that reaction. And so there was this sense that was somehow cheating. And it was also, Europe, I don't know enough about the cultural history, but I do know that it wasn't that long after the Crusades, and memories are long. I mean, we're still fighting wars in this country from before the Civil War, from the founding of our country. Our founding of even before the founding of the country. So I think some of that had to do with just sort of European chauvinism, and racism towards Arabics, towards Arabs. But it was also the way to do mathematics, and it kind of came through Italy, as I pointed out in that picture. So I think that's some of the things that he's talking about. And when you read the Greeks, we'll do a few proofs, and you'll say, why didn't they just do it a simple way, And you'll see algebra makes it simpler and more easier to understand sometimes. Okay. So one of the questions I had, and then I'll turn it over to questions, as I said I would, about other things, because I just want to make sure you have that opportunity. So I'm looking at, on her first page, she says that my argument has two key points: that mathematics operates as whiteness when we do not acknowledge the contributions of all cultures, and mathematics operates as whiteness when it is used by a standard by which we judge others. And both of those I think are things that I've been thinking about lately, as a teacher, and just in general. And so my question is two questions. So does Gutierrez think that recognizing that recognition she talks about in A, is that enough, or do we need to do more? And what do you think? Is it just enough to acknowledge the contributions? And you might, and again, I know I cut off some of the reading. And I'm going to go, and it would have been the last paragraph. So I'm going to go and read something she said from page 16. And it's right before that final section. So it'd be the last thing that I'd asked you to read. And it was, it took longer than I expected, but it's dense. It's dense. So I understand that. So she says the importance of the history of mathematics is not just to show that certain racial or cultural groups contributed to the knowledge that we have today, but also to highlight the ways in which settler colonialism or white supremacy are linked to scientific projects. And she gives an example of astronomy as being used to help develop locations of slaves. And I had never thought of that before. I don't know enough about what she's saying there. But so she's saying, I think what I'm trying to do, I'm definitely trying to do, I'm trying to do A, right? I'm trying to get us to recognize these things. But she's saying that's not enough. And again, I think that's something to think about, that we need to do more. And then another thing I thought she said, and this will be the last comment I have, and I'll open it up if you have any more, is that she says, we don't have good models for what a this is on page 12. And I thought this was a really, it's the first full paragraph on page 12. And she goes, similarly, we don't have good models for what a feminist, pro-Black, Indigenous, Latinx, socialist mathematics education would look like, or even if such a thing could exist. And so like, you know, my question there, you know, just a comment, it's not really even a question, is that struck me because like so many other fields have like studies, there's feminist critiques in a lot of different fields, and there's racial studies, which is the study of how racism has affected a lot of different things. So those programs exist in other disciplines, and so I think that's just an interesting question. I don't know. I have no answer for that. It just struck me when I read that was kind of a provocative thing to think about. Like, what would that look like? And I have no idea, and I don't even know if that's what we want to do. But I think it's a question, you know, that is, like I say, provocative, and it's worth thinking about. So, just any more comments? Actually, before I do, I just want to say a couple of things. Rather, I know today's point was to talk about events of the scholar strike. The intent of some of the people that talked about it was to call attention to current events. And I know you can't do enough of that, but I was trying to link this to something about what's within the discipline of mathematics. That seemed to me an important thing to think about, even if we don't resolve it or even agree with everything. Just it's something to think about. So that's kind of where I'm coming from on this. I think it's probably obvious that that's what I was trying to do, but I just wanted to say that's what I was doing. And I'd forgotten about that article that I wrote, and I just was thinking about it today, and I got a lot of heat for that. And part of it because the people that I attacked were some of the giants in mathematics, and I was essentially calling them racist without saying that. I was trying to be delicate. And some of the people, and there's a whole mythology that no, the Babylonians didn't influence the Greeks, and there's people have tried to disprove that. I don't know what's true, but there's certainly within the people that critiqued me, there was a real reluctance to sort of understand other paths. Like the Greeks are considered this sort of preeminent mathematical culture, and I've been guilty of that in the past. And so I felt that I was being attacked on that basis, you know, not the way that she was attacked, and it wasn't Fox or anything like that. It was just some scholars, you know, that were kind of nasty to me. But I was just like sort of going after some sacred cows a little bit, and I think that they felt hurt, and I think that reaction itself is really interesting. Okay, so that's what I have. Any more comments?
I guess I have some thoughts about it.
Sure. Yeah.
I think we should definitely recognize and talk about the issues. I guess like what we're doing right now. But I think the most we can do really is move forward while making sure those things don't happen again. But I think it's okay to talk about and to know that maybe a lot of famous mathematicians were jerks and racists and whatever, but I think it's okay to use their work, because when it comes down to it, it's about, you know, whether or not the mathematics is useful. And at some point, and this is another topic, is, you know, is mathematics discovered or invented? And, you know, did that person just discover it first, and maybe we would have discovered it anyway? So I guess those are some of my thoughts.
Those are good comments. I was talking to a professor that used to teach at Drake, Alex Kleiner, and he retired maybe it's longer than that. He retired like 6 or 7 years ago. And I said, Alex, you know, I used to always think that mathematics was discovered, but I'm thinking more and more that there's invention as well. And he said, you know, I've had that same sort of evolution of thinking. So I think Daniel's question is really interesting. I don't pretend to know the answer. I would have argued when I was younger that it was discovered, but I'm not so sure now. Okay, so this was a good discussion. As a math guy, I don't get to have. I wanted to be an English professor originally, like when I was younger, like when I was in college, and for a lot of reasons, I decided not to. But I've always been a little envious, and so thank you for indulging me today and sort of doing an Englishly kind of thing by having a reading in class and a discussion about it. And You know, I'm not saying it's as good as they do in English classes, but I appreciate that being, you know, and I enjoyed it. So we have a couple of minutes left, and are there questions about the presentations? I had anticipated when I planned today that this wouldn't be as long as it was, and that's okay that it was. But so we didn't have a whole lot of time. But are there questions about the presentations, or are things going well? And you can just, if it's going well, you can just like sort of chat it out. I'm just curious. And if you have questions, just please let me know. I mean, like, you know, we can meet tomorrow. I can find some, not tonight. Today's my birthday, so I'm off the job in about 5 minutes. But like tomorrow, you know, I can find time to talk to the groups but I haven't heard a lot from you. And so my sense is that it's going okay, but I don't want to live in a fool's paradise and be disappointed on Thursday. I know I won't be.
Are we gonna have any time to work on Thursday?
Let me answer your question with the question. How long, let's go to group one. How long do you think your presentation will be?
Probably more than 7, less than 10 minutes.
Okay. How about group two?
I would estimate about 10 minutes, and happy birthday.
Oh, thank you, Molly. Yeah. And then how about group number 3?
I would say like probably 5 minutes because it's not anything longer than that.
Hard, but you had the one. Which one did you have?
Completing the square.
Oh yeah. The sort of the obvious one or the more difficult one? You had the one. You had the one with the video, right?
Yeah.
Yeah. Okay. Good. Yeah. I think 4 had the less obvious, completing the square. How about number 4?
Yeah, I would say like 7 minutes,
Okay.
7, 8 minutes.
Doing the math, it's about 40 minutes, you know, with setup time and stuff like that. And so, in answer to your question, Daniel, if it would be helpful to have like 10 or 15 minutes before the, you know, as the beginning of the class for questions, I can do that.
Okay, that'd be great.
Yeah. Okay. Good.
Thank you, and happy birthday.
Thank you. So again, it sounds like everybody's on track. I'm not hearing anything to the contrary. Being an optimist, I'm a half full guy, not a half empty. I'm assuming that's good news. So if it's not, please let me know. Yeah. And are you going to do live preservations, film, or do you want to surprise people? I'll ask group 1 first.
We got to keep it a surprise.
Okay. How about group 2?
I think we're doing ours live.
Okay. 3?
We got to keep everyone on their toes and surprise them.
Good. Okay. 4?
We are going live, yes.
5. Okay, good. Okay, that sounds good. So that's all I have. I can stick around for a few minutes. I didn't mean I'm gonna like to, you know, I always stay around after class, even on special days. So like if you have questions or anything, I'll stick around for a few minutes. Okay, I find that fun. So otherwise I'll let you go.
Have a good rest of your birthday.
Okay, thanks, Eric.
Happy birthday, Dr. Alexander.
Thank you, Daniel.
Happy birthday.
Thanks, Avasar. I'm sorry, I know you told me before.
Sir.
How do you pronounce your name again? I'm sorry, I missed it.
Sir.
So Avasar?
Yep.
Yep, okay, thank you.
All right, so I'm sorry I'm going to take your time, sir. I actually have quite a number of questions.
Ooh, we don't have time for quite a number. We have time for a couple.
Right, we have time for a couple. So, yeah, speaking of the second article that they were reading, I didn't read it because we don't have time.
Sure, that's all right.
And like speaking of like racism and stuff, right? Because we have that a lot as a Chinese.
I didn't hear what you said. Sorry.
I'm saying like the about the second article about the
Yeah.
racism